Hello, and welcome to session 2 of our technology training, Developer's Guide to the SM Innovation Platform. I am David Wickman, a software development manager here on the CESMII platform team, and we'll be guiding you through our second half of training. During our training time together, we will be addressing 3 different topics with lots of information in between. We'll be going over the standards and open specifications, the developer's interface to the SM platform, and tying it all together by using the SM platform data, Python, and Excel. I hope you have a nice cup of coffee with you because we are going to get right into it. Our first stop in the developer's guide to the SM Innovation Platform are standards and open specifications. These standards and open specifications help CESMII to democratize smart innovation in manufacturing by following and building upon an open standard. The OPC UA specification has been designed for scalability and supports a wide range of application domains. As you see here, the OPC UA specification is built on the following infrastructure of protocol mappings, discovery, and information access, with the information models layered on top. With this multi-layered architecture, new information models can be created based on the OPC UA data model and eventually derived from the OPC UA base information models. These information models come in 2 parts, the companion specifications and the OPC UA node sets. The companion specification is the human-readable version of the information model. Let's take a look at a companion specification. This is an example of the companion specification for robots. This joint companion specification can be found at reference.opcfoundation.org/robotics. Here you'll see a human-readable document describing the load type for robotics. This load type is just one of the object types of robotics. Additional examples of companion specifications can be seen on the OPC Foundation's website. Now that we know that the companion specifications are the human-readable versions of a particular specification, we can now move on to the OPC UA node sets. Let's take a look at an OPC UA node set. Here we see a screenshot of a section of the robotics node set. As you will notice, we are looking at the same object type of robotics called load type. This is simply an XML document describing different objects, children, properties, references, and variables of the robotics node set. We first started with the human-readable requirements definition, the companion specification, and eventually produced an XML file or node set that can be universally used to describe data coming from a robotics device. Why is this important, you ask? Now that we have the data in a consistent, reusable structure, we can easily ingest this data into the SM platform using this node set, or as we refer to it at CESMII, the SM profile. The SM profile is an open standards and open specifications approach we have taken here at CESMII to democratize smart manufacturing. Here you can see a few of the robotic object types inside of the CESMII Smart Manufacturing Platform. We have taken the robotics OPC UA node set and have loaded it into the Smart Manufacturing Platform, allowing the platform to understand the data coming from the OPC UA server. This easy-to-use, standards-based SM robotics profile can now be reused across any operation that utilizes an OPC UA server to handle their manufacturing data. Let's talk about the developer interface to the Smart Manufacturing Platform's object model and how we can move our data in and out of the SM platform. Even if you aren't familiar with web programming, you probably have heard of the term RESTful API. What is RESTful API, you ask? REST stands for Representational State Transfer, which allows an application to request pre-prepared sets of data over a web connection with a unique URL for each set of data. This will often require the developer to filter out unwanted sets of data or even make a follow-up RESTful API call to get additional data sets. With the amount of data being collected, we here at CESMII have opted for a different approach to query this data. This approach takes advantage of GraphQL. GraphQL stands for Graph Query Language and allows the developer to create arbitrary requests or updates to this data using a common URL for all requests. The application can easily pass its request with filters or joins, which can drastically reduce the amount of data being sent to and from the server. With many supported libraries and tools, GraphQL's built-in, self-describing schema was the ideal choice for industrial manufacturing systems. Before we get into creating our own queries in GraphQL, let's take a look at the graphical interface, which helps us build queries that can be used in our applications. Here on the right, you'll see a screenshot of the graphical interface that is available in the SM platform. The first column is the Explorer. This helps build a query using the self-describing schema of the endpoint. The next column is the actual query built using the Explorer. This can be copy and pasted into a programming environment of your choice, whether that be .NET, Python, Java, or JavaScript. The third column is the response. All we need to do is hit the play button, and our response will be sent back from the server based on the query information that we just sent. And the final column on the right-hand side is the auto-generated documentation that explains the schema. Now that we have taken a look at the GraphQL here in PowerPoint, let's switch over to the browser and build some of our own queries against the SM platform. All right, so let's take a look at our SM platform here and start working on some of these various different queries. So the first place we want to go to, you can see at the top here, we got sandbox.cesmi.net. This is kind of our development environment where we can play around and see how things work. So what I'm going to do is go ahead and click on the login. And I already have my username and password all set up. If you do need to create accounts, you can create accounts down here and we'll get that activated for you. So we're going to go ahead and log in. So this here is kind of the landing page of our SM platform. And you'll kind of have seen this in some of the various other videos. But what we want to do here is we want to take a look at some of these different areas in the developer section. So just like we had talked about in the last couple slides here, we have our graphical section here, where we can kind of play around with some various different queries. So we're going to go ahead and click on that and take a look at what graphical has in store for us. So inside of here, you can see we have some queries and stuff that we have previously have set up. But inside of here, this is where we can go ahead and set up various different queries to take a look at how graphical is grabbing our data and what kind of data is being returned here in this third panel. So one of the great resources that we have over here at CESMII, over at our GitHub, which you can take a look here. We got github.com/CESMII, and this is in our API repo. Inside of here, if you query down, we can take a look at some of this information. And this here is our section on the SMIP, or the Smart Manufacturing Innovation Platform queries. And these queries here are kind of a way to get you started on some of the different GraphQL queries that we can play with. So we're going to go through a bunch of these different queries and show you how to do it just by copying and pasting. And then we'll also build out some of these queries together. So the first query that we're going to look at, this following query, is a payload return of all the different equipment types. So before we go ahead and get into that, when I say equipment types, what does that actually mean? So if we go over to the platform, we click on model here, and we go to our physical model, we'll be able to take a look at the different equipment types that are inside of our platform. So we have multiple different tabs here at the top, but right now we're going to focus on this equipment types. So inside of here is a list of all the different equipment types that are in this sandbox version of our platform. And what we want to do is we want to create a GraphQL query that will go ahead and query and return back all of these different equipment types. So we're going to go back over to GitHub, and we're going to copy and paste this information. So I'm going to highlight this here. We're going to copy it, and we'll go jump over here into GraphQL, highlight all of our information, and all we're doing is pasting that inside of here. So when I hit the little play button here, this equipment list query should return back our information. Well, looks like we have a permission denied for a few things. So the first thing that we definitely need to do as we're developing in this graphical interface here is get our web token. So to get our web token, all we go over to is our physical model here. And then again, we'll click on developer, and right here, request header token. So we just open that guy up in a new window, and you'll see we have a authorization bearer token, and no need to actually type all this stuff. We're just going to copy and paste it. So we're going to copy it there, go back over to our graphical interface, and we want to put this down here into our request headers. what this will do is right now we have an authorization of null. So it means that we're not pasting any authorization in there and passing any of that with our actual query. So what we want to do is we want to pass that bearer token that we have from the platform. So that way the platform and GraphQL knows that we are allowed to access this information. So now that we have that header information here, we're going to go back up to the top to the play button and get our data. So now you can see that this data has been returned from the platform, and all of this information is directly in here, and we're able to see all the different equipment lists inside of our platform. You'll notice that all it is a simple GraphQL query with our request headers, and we get returned back all of this data. So let's go ahead and take another look at a different query. So if we want to expand this query to take a look at a list of the equipment types and take a look at what actual profiles we have inside of the platform, all we do is copy and paste this guy here. We'll go back over to our graphical interface. And then we'll go ahead and click on the play button. So you notice that we have a bunch of the same information here, but if you take a look at this one here, we have our generic equipment type and we have our type by ID. So these are the various different instances of that particular equipment list. So we'll keep scrolling down, see if we can find another one in here. And here we go. And we got another one here. This is motor equipment type. So we'll see that we have equipment type by ID. We are using one for what is called a motor, as well as another one that's called a PPK motor. All right, so let's take another look at another additional query. So let's say we want to take a look at all the different equipment types that are defined locally. And when I say defined locally, so we have our equipment types here. And if we go over to our library, that's this section here, and we select local library, we'll get a list of all these different equipment types that are just defined locally. So if we want to grab just those local ones, we'll go ahead and paste that particular query in. And again, we'll go ahead and hit our play button. So you'll notice that's the same information here that is returned from that graphical query. We're able to see all those different local equipment types based off of one query inside of here. So the difference between this and what we would have on our REST API call, if we did a REST API call to say, let's say equipment, it would return all that various different equipment, and then we would have to filter it down again. The beauty here with GraphQL, we're able to say, hey, we want to conditionally grab just the local library, right? So just that local library here, instead of all the libraries, and be able to return those just on one side. So we don't have to change anything on the back-end part of the API. All we're doing is changing that query that we're setting up here in Graphical. All right, let's take another look at equipment querying. This particular query returns a list of all the different equipment that is inside of the platform. So again, if we go over to our physical model, we take a look at equipment, and we'll look at all the stuff in here. This is all the different equipment that is an instance of these equipment types. So let's jump over to Graphical, drop that query inside of here and hit play. And now we can see that we have all this different equipment that is utilized inside the platform. Another query that we can take a look at here, this is the locations. So I'm gonna go ahead and copy that. And again, over here in the physical model, before we had our equipment types and the what we call places. So each one of the equipment types has its own place that it needs to take a look at. So these places or locations, this is how we would get those various different locations in the graphical interface. So go ahead and paste that in there. This is our places query, and we're able to see those same locations here that are returned back from that particular response. Another thing that's very useful is querying various different attributes. So we're going to copy this particular attribute query, go back to our physical model so you can take a look at where the attributes are. So these are our attributes. We click on the attributes and we can see all these different attributes that are being utilized here in the platform. So if we wanted to grab a list of these attributes, all we'd have to do is paste this particular query inside of here, run that query, and we can see that we have all the different attributes: the temperature, pressure, valves open, temperature in, temperature out, and so on and so forth. Now that we have a list of all the different attributes that are available in the SM platform, let's take a look at how we would get attributes for a particular equipment type. So the first thing we want to do is go over to our physical model and take a look at our equipment types. So once we're in our equipment types, we need to grab an ID that will help us identify which one of these equipment types we're going to look at. So first thing we do is we click on our columns, go over here to the ID, check that box, and hit OK. So now that we'll see we have our IDs over here on this side. And what we're going to do is we're going to take a look at the different attributes of this boiler drum. So if we go over to boiler drum and we click on this little attributes grid, you can see that we have volume and online. So let's go ahead and grab this 34330 ID, and let's go ahead and use this over on GraphQL. So now inside of GraphQL, what we're going to do is we're going to go ahead and build out our query. So inside of our query, we're going to go ahead and click on equipment types. And then we want to be able to filter. We're going to filter on the ID we just grabbed. So that ID we just had, we're going to make sure that is equal to that 34330. And then some of the other information that we want to get in addition to our filter will be seen down here in this blue color. So let's go ahead and grab our ID, and then we'll grab our display name so we can kind of see what's going on there. So we can make sure that it is that boiler drum. And then in addition to that, we want to grab our attribute types. So to grab our attribute types, we go down to this type, attribute types. Then again, we're going to select which sets of information that we want. So let's go ahead and grab our ID as well as our display name. So we can see kind of this was our result before. We had our display name and ID. And then when we run this query, we're going to get the attributes just for this ID that's equal to 34330. Let's go ahead and click our play button and get our information back. So there we go. So now we have our ID, that 34330, that matches up to our search and our boiler drum. Then we have volume and online, which that also matches up to the information that we're seeing over there in our physical model. So now that we have that information that we're able to pull back various different queries and attributes from a particular equipment type, let's go ahead and take a look at another way that we can grab information through a history query. So this one is actually pretty interesting, where we'll be able to build this out. So what we're going to do is we're going to show you how to build out a history query from some information that we are seeing in the platform. So the first thing that we're going to do is we're going to go ahead and look at all of our information here. So we have this top here. So this query, this is any arbitrary name that you want to use. So inside of here, instead of attribute query, we're going to call this one, let's call it our history query. So we notice that when I updated it here, it also updated it here. And since we're going to be getting information from our history, we're going to go through and look at which one of these queries could help us. And right here, we've got get raw history data with sampling. That's the one we're going to click. So we're going to go ahead and select that. And with this query, we can use these query parameters here that are in the purple. So that information that we're going to grab, we're going to go ahead and grab IDs, which just essentially will just be an array of IDs of that information that we're trying to get back, as well as a start time and end time. So we've got a start time and an end time, and we're going to fill those information in just momentarily. So after we have those query information of how we're going to get that query. Now let's see and add the things that we want to that query to return. So let's go ahead and add the float value. So this is going to be the value that is returned and what that value is in that time series data, as well as our timestamp for that time series. And then we'll go ahead and add an ID just so we can see kind of what's going on. So in order to get that the IDs attribute here, let's go back over to our physical model inside of our platform here. So what we want to do is next go over to equipment, and we're going to take a look at our boiler east. And our boiler east, we want to take a look at the these attributes here that are on our pipe in, as this is the information that we are going to want to grab that time series data from. So we're going to go ahead and click on this one here. And this is going to pull up our attributes. And we don't want to really know if it's online or offline. We want to take a look at what the actual flow rate is. So if we take a note of this here, so we got 34338. So this is our ID that we're going to be looking at and using to grab that time series data. And then you also notice that this data source here, this is coming back from an OPC UA server that we've linked up with our profile. So that way we can get the correct data for that flow rate. So let's grab that number, 34338, and we're going to put that over into graphical. So we got 34338. And then we are also going to grab some timestamps here. So we have our start time, and then we're going to have our end time. And then after we have that history query all set up here, so we have our IDs, our start times, our end times, and then we want it to return our float value, as well as the TS or timestamp, and then the ID as well. So after we got it set it up, ready to go, all we got to do is click our little play button. So now we click our play button, and over here in that response, we'll see that we have our float values that are changing, 0, 26, 31, 0, 61. So these are our flow values that are being passed up to the platform, and now we're able to query those easily inside of the platform and take that data that's inside the platform with the GraphQL and be able to use this either in another application or further analysis upstream. Now that we've taken a look at GraphQL's query feature, let's take a look at another great feature with GraphQL called mutations. Let's first head back over to our GitHub here and take a look at the documentation we have on mutations. So as we scroll through here, we'll find various different information that will be helpful for us, just like we did in the previous queries with GraphQL. Finding that ID is going to be very, very important to make sure that we are mutating or changing the data that is coming back from the platform. And making sure that we're using that on the correct ID. We want to be very, very careful with this, because as we do the mutations, there is no undo for that particular mutation. So let's go ahead and walk through one of these example mutations and take a look at how this mutation will affect the data that's being given to us. So the first thing that we're going to do is take a look at the structure of the mutation. So at the top, just like we had query before, now we're going to have mutation with the name of the mutation that we want to talk about. And in this case, we're going to be just replacing a time series range for that mutation. So the first attribute or tag ID that we're going to be looking at, that's going to be that ID of the data that we're going to be changing and updating. Next up, we have our entries. So our entries is going to be what part of the data that we're changing. In our case, we're going to be having a few different timestamps and those values. And then note here, this is very, very important. So the start time and end time, when we do add that these attributes here to the replace time series range, what it's going to do is it's going to replace anything that's in this range. So in this case, February 2nd to February 3rd with just this information inside of entries. So if we had other data inside of this time frame, it would go ahead and replace all of that data with just these 3 entries. If we were to exclude the start time and end time, all it would do is either update this particular set of data into their respective timeframes, or if those timeframes already existed, it would update those values to what they are. So let's go ahead and try this out on some of the data that we're working with here in the platform. So the first thing we're going to do is we're going to go over to GraphQL again, and we're going to be working with this ID. So this ID that we got here, we can find that over here on the physical model. We go to our boiler east, we take a look at that pipe in, look at our attributes, and we'll see we have flow rate and online. So if we want to look at that ID, we click on column, checkbox next to ID, and hit OK. And we'll see we have that 34338 there that we're going to be using and updating. So before we use it and update it, let's go ahead and do our basic history query on that and see what kind of data that we have for this time frame. So we ran that query, and it looks like we have 3 different values that are given back to us. So these 3 different values are here currently in our platform. So we want to go ahead and do a mutation on this particular ID. So when we do that mutation, we're going to go ahead and we'll copy and paste this example here over to our GraphQL. And we don't want to lose this ID. So we're going to copy this ID so that we are doing the same mutation on there. And then we'll go ahead and get rid of this. And I already have a few values queued up for us. So that way we can take a look at what those are and how they are added to the system here. So I went ahead and pasted those in there. And for the time being, I'm going to take out this start time and end time because I don't want to wipe out any values that might be there during that time. So we can go ahead and hit play on this, and then we'll notice that we have no rows deleted, 3 rows are inserted. So if we go back to the history query that we just did, so this is our history query, and we query during this time frame, we're going to see that we have multiple rows that weren't there before. So these 3 rows that were originally there, and then these 3 rows at the top that are now inserted because those are those values that we just provided to it. Now, let's go ahead and do that same mutation again, except this time, let's go ahead and instead of actually having these entries here, if we have these entries removed, and then we have that start time and end time, so in our case, that 920 to 921, what that's going to do is actually going to wipe out those 3 values that we currently have in there because we didn't provide any entries for that particular time frame. So if we go ahead and run this mutation, we'll do the history query again, and we'll see those top 3 are removed. So we'll see rows are deleted 3, and then rows that are inserted none. So if we go ahead and go back to our history query, hit play, we should see just those 3 rows that were there before. Now this is definitely good and helpful, but we just need to be careful too when we're doing these time frames. So let's go ahead and insert those 3 again inside of there and show you how this works with that start time and end time. So if we run our history query, we'll see we got our 6 values, which is great. But if we were to run this, and let's say we just had 2 values, right? Or 1 value. So we're just going to insert 1 value in, except we have the start time and end time in there as well. We'll notice that we're only going to be getting rid of those 3 values that were there before and just adding this 1 value back in. So now that we ran that query, let's go ahead and, that mutation. Now let's go ahead and run the history query, and we'll see that we have those 3 that were from before. And now because we had that start time and end time, there is only one value that is left in there. So definitely be careful as you are doing mutations to make sure that you understand what values that you're updating, what values you're deleting, and what things might be overwritten. Because there is not an undo button here when we're using GraphQL to mutate our data. Now that we have some basic examples down of querying and mutating here in GraphQL, let's go ahead and jump into an example here with the get raw history data with sampling, not only using GraphQL, but using Python and Excel to take and extract this data from the SM platform, create an Excel file, and open that Excel file open with this data that we're going to see here. So let's go ahead and start with the ID. So remember that the ID here, this is the key component here that lets us know which piece of data that we will be sampling. And we'll go ahead and hit our play icon, take a look at this, and this is all the wonderful data that we're going to be pulling back from the platform using Python, and then taking that information, formatting it into an Excel document so we can kind of view this stuff offline outside of the platform. So first thing what we're going to do is we're going to go over to our GitHub repo, and we're going to go ahead and pull that down. So pulling that down is simply as selecting the URL here. Go ahead and open up your terminal or command prompt and go ahead and pull this down. So we're going to do a git clone right here into the repo. So as soon as that information pulls down, we can take a look at what folders we have here, and we'll notice that we have an API folder here. That's right where all that code just went. And we'll use this output folder later to store our Excel documents. So let's go ahead and open up our API folder. So we have API and demos, and then inside of demos, we have our Excel demo. Inside of here is going to be all the code and samples that we need to get started. So I'm going to go ahead and open up Sublime Text. You can open up whatever text editor that you like and prefer, but this is the one that we're going to be using today. Also note that I am on a Mac computer. The samples and things here will also work just as fine with a Windows box. So the first thing we're going to take a look at here is our Python to GraphQL to Excel. And what we're going to be doing is taking a look at importing all of this, all these different items here through pip. And then we're going to be using our smart manufacturing innovation platform as GraphQL to pull all these things down. So the first thing we need to do, we take a look here, we have to copy our config example to a config.py, and we're going to set all of those values. So let's go ahead and run through that. So we're going to take this, we're going to go ahead and duplicate this, and we're going to duplicate this as a, go ahead with config. And all this information here, we're going to be gathering from the platform. So we're going to be switching back and forth between here in the platform, so we have all of our information. So the first thing we want to grab here looks like our authenticator. So let's go run over to the platform real quick and grab our authenticator. So we can go to our developer and authentication management. So you go ahead and click on there. And this is going to pull up all of our authenticated resources. For this one here, we're going to be just using the CESMII demo auth as our authenticator. So we'll copy that, hop back over here. So our authenticator is just CESMII demo auth. Our password, I kept it simple, just CESMII demo auth 11. And then one of the other things that we need to add here is this name. So this name is what your username is for when you log into the platform. So in my case, my name is David Wickman, and the role we're also going to grab from the platform. So the role is going to be one of these roles over here that your authenticator name has. So we have, in our case here, we have sandbox underscore group, sandbox underscore RO or read only group. And we're going to go ahead and do the read only one for this particular demo. So we're going to copy that, paste that in, and then our URL, as always, is going to be some type of alias here with .cesmi.net/GraphQL. In our case, it's sandbox. So notice that in this part of the platform, we have sandbox.cesmi.net. So that's going to be our authentication URL. And then we have bearer token. So bearer token, this is going to be the part after the authentication for our bearer token. So we're going to pop back over here, go down to developer, request header token, and we're going to click on that. That's going to give us this authorization key value pair, and we want to copy this bearer token here. So we'll go ahead and copy that. We'll drop it over here in our config file. And then the next thing it's going to ask for is our tag IDs. So these tag IDs are what we just looked at inside of the post-GraphQL graphical interface. So this ID here is what we're going to be using because we want to get the same data that we have on this side. So I'm going to go ahead and copy that guy. We're going to drop it into this here for our tags ID, and the rest of the time offset and end time offset, don't need to worry about that. We'll be good. And then we have the next section down here. We have our auto open. So this is just a Boolean value. So 0 won't auto open Excel, and a 1 will open Excel. So for output files, we're going to go ahead and since I'm on a Mac, we don't want to put this in a temporary file. So we're going to put that in that output folder that we had talked about before. And then for the Excel command, you'll note that down here, if you're using a Mac, you need to use a little bit different of a command, which is fine. So I'm going to go ahead and copy and paste that particular command in here for my particular setup. So that's all we need to do inside of this particular config.python file. So we're going to go ahead and save that. And what this is going to do is it's going to go and first use this smip.py and authenticate. So this GraphQL authenticator, this is all also available inside of the demo things inside of our GitHub. So you'll be able to take advantage of that. And then this Python to GraphQL to Excel, this is going to take that authenticated bearer token, go and make the GraphQL call via command line. And then it's going to auto create an Excel document with all of that data that we had seen over here, except formatted by the ID, timestamp, as well as the actual value, the float value. So let's go ahead and run that particular Python file. So we have our, we're running Python, so we're going to do Python 3, and then we're going to pass in our Python file. So we got Python, GraphQL to Excel.python, and then we hit enter. We're going to create all those files. So right now, looks like Excel is opening, and it is open. So we can go ahead and take a look at this here and expand these out a little bit. So we got our ID, which is that ID that we are looking for right here, as well as the timestamp and then the float value. So that's an easy way to take that information that is directly here in the platform with a simple Python script, be able to add the authentication values there, drop in our ID, run a quick terminal command, and output a Excel file that can be used for other data platforms or other analysis in other areas. This concludes a session of our Developer's Guide to the SM Innovation Platform. We hope that you were able to gain new insight into standards and open specifications, the developer's interface to the SM platform, and using the SM platform data outside of the SM platform. If you need any additional information, please refer to the best practices for developers slide, or feel free to reach out to the platform team at devops@cesmi.org.
Awesome. Thanks, Dave. So we had a couple good questions come in live. I'd like to take a few of them. Richard wants to know if there's an on-prem solution in the works. And this is obviously a larger conversation, but let me try to hit a few bullet points from it. first we'd have to define what we mean by on-prem. So if by on-prem we mean moving the whole thing into a single factory, probably that wouldn't be our normative pattern. There is at least one installation that runs in a private data center that covers multiple factories. But really the goal of the platform is to establish a graph of the process units in an enterprise. So you necessarily have to be somewhere above more than just one plant. So private data center is supportable. We can deploy the software there. It creates some additional challenges with kind of ongoing maintenance of the software. It's designed to be software as a service. So we would like to be able to continue to keep that software up to date. That's a little bit more challenging if it's a private data center, but all of those things can be worked around in a commercial scenario. We can certainly have that conversation. What we're not looking to do is have a server under somebody's desk somewhere in each factory or each plant that runs an instance of the platform. The scope that we could build a graph on would be too limited, and plus all of those additional challenges. But if we want to be a little bit more wishy-washy with our definition of the term on-prem, where I would like to be able to run some computation close to the data source, that's 100% in the works, something we're thinking about. So whether it's a private data center or a cloud data center is almost immaterial. The bulk of the computation, the bulk of the graph is established at some level of context above a single line or single plant. But then some computations are more appropriately run really close to where the data is being generated. So we'd still like to be able to orchestrate from a level above, but be able to push a computation close to that source. So now we're talking about edge computing if we want to introduce buzzwords. And so we're definitely thinking about that. It's part of the gateway strategy. And there's a couple really interesting open source projects that are potentially very useful there. But I'd say it's early days and maybe next year's demo. No promises, we'll look something like that. So private data centers, sure, in a commercial arrangement. Again, for the free version during kind of research and exploration, we're going to keep it to the lowest cost way to do it. But in a commercial arrangement, we can have that conversation. As for on-prem, meaning edge compute, definitely on the roadmap. Would love to continue that conversation. How do we first make the connection with the database and pull the information into the Explorer? It's a shame this isn't a very interactive conferencing platform. So there's two things you might mean by that question, and I'd like to try to hit both. So if the first connection to the database is about getting data in, you need to kind of wrap your head around the limitations of most manufacturing data sources. The most rich common model that we can rely on is a key value pair. Most PLCs will give you a tag name and a tag value when asked. Most devices, whether they're new or old, have a topic or a memory location that you can probe or get a push message from. So key value pair is all we can expect. So the initial connection to the platform, if you want to push data in, has to establish the keys and then can begin pushing the values. There are two ways to set up that initial connection. One is with a formal connector. And the sample code for building a connector adapter is on our GitHub. The interface for the connector, the iConnector interface, has two members that you might expect. One is list all the tags, and the other is give me the current value for a tag. So if you want to push data in that fashion, you have to make the data look like manufacturing data. You have to list the tags that you service, and then you have to respond with the current value of one of those tags. There are any number of protocols that can be adapted to that pattern. MQTT and Sparkplug are popular right now. OPC DA is very common. but you can map anything to that structure. The other way to put data in is with GraphQL. And again, you first must establish the tags or attributes that you're about to push in. You can do that visually, like Olivia showed, or you can do it programmatically through a mutation like Dave showed. You can set up the attributes for which you are going to push data. And then you can use GraphQL to send mutations that update the current value or send a batch of historical values. But the first connection to the database, if you're pushing data in, will be to establish the keys and then to establish the values of the data that you want to push in. If you want to pull data out, it's going to be through GraphQL, through what Dave just walked through, where you find the IDs for the tags or attributes whose data you're interested in. And you can do that visually, or you can do that programmatically. And then you make queries against those IDs for either the current value or a range of historical values. The graphical web interface is designed to make it very easy to do your first exploration with that. So you need just what Dave showed. You need a web browser, you need to go get a bearer token from your platform instance, and you need a tab with the graphical interface up and some sample queries that are on our GitHub, or that you can design right in the graphical tool by kind of interacting with that left panel. Those are the two kinds of connections you can make: push data in, get data out, and almost every scenario comes out of those. If we are a project team funded by CESMII, what are the steps we need to take to engage with your team and get started on this process to connect our assets to the SMIP? So if your project has been selected and approved and all the paperwork is done, you'll be hearing from us shortly with your platform instance instructions on how to register your first account, which will then become an administrator for your platform instance. And you'll be able to get started. That email will also include a link to all of the resources we talked about today. The best ways to engage with the three of us are the DevOps email address, or even better, the Discord server. So we're all active on there, and other project teams are active on there, and some of the vendors who have contributed technology are active on there. So we can help the fastest that way. So if your project's selected, all you have to do is wait for that onboarding email and jump in, refer back to this training if you get stuck, or hop on Discord and ask for help there. We've yet to lose a project team. I'll put it that way. Everybody's made it through that initial onboarding. Olivia, do you want to take this one? Can you connect to multiple data sources from the same connector?
Sure. From my understanding, no. It's a one connection per connector. So you either have to have a few different edge devices, whether that be I used a PC to show you today. You can also install it on an edge device like a Raspberry Pi. So if you need to connect to multiple sources, you'd need multiple installs.
Yeah.
Or loop it all up into one endpoint.
Yeah, there's two ways you could kind of do multiples. One is the connector can be virtualized. So if you've got a rack and you just want to run a bunch of VMs, each with its own connector, you can do that. The other is most manufacturing protocols can be marshaled through like an OPC UA broker. So CESMII member Matricon has a product whose name's escaping me right now, but it allows you to marshal multiple data sources through their drivers to a single OPC UA endpoint. So from there, you could connect to a Rockwell PLC and a GE PLC and a Siemens PLC and a Historian, bring them all up via their own proprietary protocols or APIs into an OPC UA endpoint, and then you could connect to that and effectively marshal multiple sources. All right, we're close to getting the crook here on time. I think I'll just wrap up by saying, please visit the GitHub. There are two main sections there for developers. The API section has the demos we showed you today, demos we did last year, sample code in multiple programming languages, sample GraphQL queries, sample mutations, detailed instructions on how to get a bearer token, both visually and programmatically, how to configure your bearer token access level. So you're going to default to read only, so you don't accidentally make a mistake. But when you're ready, you can change that to read and write, so you can start changing or mutating the platform. We're going to do a little bit of cleanup on our demo section, just because we've been working hard to get all these demos ready. But you're welcome to look through our code. I will also accept pull requests if you can find ways to improve our code. The other side is the connector side, where if you need to adapt to a protocol and you want to do that in the formal fashion, you can also build connector adapters that can plug into the edge layer. So everything you need is there, or if it's not there, identify the need and we'll work to get it there for you. And Discord's the best way to reach us. All right, I think that about wraps up this session. Looking forward to hearing from you as you dive in. Thanks, Dave. Thanks, Olivia. Awesome.